10440 battery. They're like the little brother of the more common 18650 battery, but they're the size of a AAA battery instead that I've been using in my projects lately. Today I'm looking for ways to charge them using these TP4056, which are typically made for charging lithium-ion battery. And I'll be using two of them to charge two batteries separately. This is to avoid any cell balancing issue for safety reasons. Normally, this charger comes with resistor that's rated at around 1.2 kilo ohms. That would roughly translate to 900 to 1000 milliamp output, which is fine for a bigger capacity battery like the 18650, but it's generally safer to charge lower capacity batteries at a lower current output. And it seems like we're looking at around 200 to 250 milliamp output for the 10440. Thankfully, we can swap out the resistor to something of a higher value to do so. Using this tiny vise, I'm first removing the R3 resistor. That's the part that's responsible for determining the charging output. After bending my resistor to fit the R3 soldering pads, I have some initial success. But I managed to rip it out in just a few minutes, so I don't recommend doing it this way, unless you're using surface-mounted resistor. So if you're following along and using a through-hole resistor like me, I would recommend soldering directly onto the programming pin of the TP4056, which should be the second pin here. For the other side of the resistor, I am just connecting it onto the ground pin here for a much stronger connection. And the next step here is just connecting the battery holder to the charger output. Before proceeding any further, I would just like to check that everything's working correctly. Using a USB tester, I've confirmed that the charger is only outputting 230 milliamp for a single battery, just as what we were expecting. So I made a second pair of these to connect them in parallel. And that should allow me to charge both of these batteries using a single USB cable. With the help of some tapes and some shaky hands, I've connected the negative directly on the new resistor since they're already occupying the ground pins. At this point, we're kinda done. Both USB should be functional and we're getting 460 milliamp for charging both batteries at the same time. But I want to take this one step further. Taking the measurement of these components, I've made a simple design that can be 3D printed to hold everything in place. If you're feeling fancy, give it a fuzzy skin here like I did. I've still kept the internals smooth so the parts could fit properly. This print does require a small amount of support, but I've made some holes at the bottom of the enclosure for easier removal. Instead of glue, here I'm just using some double-sided tape to secure the charger in place in case that I ever need to take this out again. I'm taking extra care sliding this cover in as it is a tight fit and I wouldn't want to damage any of these components. Toward the back, the snap feeds should just click in place. I've broke them in my testing, but I've since made it thicker, which should hopefully solve the problem. And that's really it. For about $1 in material costs, that's how you can make a charger for your smaller batteries. STL file is in the link down in the description. If you liked it, a thumbs up goes a long way, and I'll see you in the next one.